You know, when you think about air quality, your mind probably jumps to things like smokestacks and car exhaust, right? But what if I told you that a huge part of the story is actually right under our feet? In this explainer, we are going to dig into the surprising and absolutely critical link between the soil on our farms and the very air that we breathe. And just to get a sense of the scale here, look at this. Agriculture, forestry, and how we use our land, together they account for almost a quarter of all human-caused greenhouse gas emissions. That's a slice of the pie that's just as big as all global electricity and heat production combined. So right away, that tells you something really important. How we manage our land isn't some small side story. It's a massive piece of the climate puzzle.
Okay, so where are all these emissions coming from? Well, let's start with the invisible culprits, the really potent greenhouse gases that are released through everyday farming.
So first on our list is nitrous oxide, or N2O. You can kind of think of it as carbon dioxide's much more powerful cousin. Even though there's less of it in the atmosphere, molecule for molecule, it's about 300 times better at trapping heat. And yeah, one of its main sources, you guessed it, agriculture.
So how does a farm actually create this gas? Well, a big one is nitrogen fertilizer. When you give soil microbes this huge dose of nitrogen, way more than the plants can use at once, their natural processes can end up releasing some of it into the air as N2O. And you know what? The same thing happens when manure and leftover crop stocks just decompose naturally. It's all part of this really complex cycle happening in the soil.
All right, next up is methane, CH4. This is another powerhouse greenhouse gas. And in the world of agriculture, its origins are almost entirely biological. We're talking about gases coming from the digestive systems of animals and from microbes that are just thriving in wet, soggy environments with very little oxygen. Now, the biggest agricultural source might actually surprise you. A huge 40% comes from something called enteric fermentation, which is really just a fancy scientific way of talking about the digestive process of livestock. We're mainly talking about burps from cattle. After that, you've got flooded rice paddies and how we manage manure as the next biggest contributors.
And we can't talk about manure without mentioning ammonia. I mean, most of us know it for its really strong odor, but its impact actually goes way further. Ammonia that's released from manure is an indirect source of nitrous oxide, which connects our soil management practices not just to climate change, but also to local air quality and, of course, odor issues.
So we've talked about the invisible gases, but agriculture also produces pollutants that we can see, the dust and the smoke that literally rise up from the land itself.
The story of these visible pollutants really starts with bare soil. Practices like intensive plowing or tilling and letting animals overgraze can completely strip the land of its natural protective cover. And this leaves the soil totally exposed and fragile, basically ready to be swept away by wind and rain.
This leads to what we call particulate emissions. So on the one hand, you've got dust. And this isn't just plain old dirt. It's the most fertile layer of our topsoil, filled with nutrients just being carried away on the wind. Then, on the other hand, you've got smoke and soot from things like burning what's left of the crops after a harvest. Both of these directly pollute the air and really harm the health of the soil.
Okay, so we've laid out the problems, but here is where the story gets really hopeful and, honestly, pretty exciting. Agriculture also holds some of the most powerful solutions, and this brings us to a concept called climate-smart agriculture. The goal here isn't just about cutting emissions. It's about building entire farming systems that are more productive, that are more resilient to climate shocks like droughts, and that actively help fight climate change. It's about tackling all these challenges at the same time.
One of the key strategies for this is called conservation agriculture, and it's built on three really important principles. First, disturb the soil as little as possible. That means way less plowing, which protects the soil's delicate structure and all the life inside it. Second, always keep the soil covered. You can use leftover crop bits as a mulch or plant what are called cover crops to act like armor against erosion. And third, mix it up. Rotate what you plant to improve soil health and naturally keep pests in check.
Now, this is where things get really powerful, because when you start applying those principles, something incredible starts to happen. The soil literally transforms from a source of emissions into a solution. It becomes a massive carbon sink.
Just look at the difference here. Degraded soil, it's compacted, it's pretty much lifeless, and it's constantly releasing carbon into the atmosphere. But healthy soil, the kind that's rich in organic matter, does the exact opposite. It pulls carbon out of the atmosphere, it holds on to water like a giant sponge, and it's teeming with life, creating its own natural fertility. This whole process actually has a name: soil carbon sequestration. It's basically nature's own technology for drawing down CO2 from the air. Plants grab it through photosynthesis, and then when they decompose, that carbon gets locked away into the soil as stable organic matter. And it can stay there for decades, maybe even centuries.
So how do we actually do it? Well, these practices should look pretty familiar by now. They're the heart of conservation agriculture. By leaving residue on the surface, planting cover crops, and ditching the deep tilling, we are actively feeding the soil and helping it store more and more carbon.
And if you need just one stat to understand how incredible this is, here you go. For every single 1% increase in soil carbon, the water-holding capacity of that soil doubles. That is an absolute game changer. It means crops can survive droughts better, you need less irrigation, and farms just become so much more resilient and sustainable in a changing climate.
So what's the big takeaway from all this? It's that our connection to the land, to the soil itself, is so much more impactful than we usually give it credit for.
The very same soil that can release potent greenhouse gases and lose its most fertile layer to the wind has this incredible potential to do the complete opposite. It can become one of our greatest allies in fighting climate change, cleaning our air, and making sure we can feed a growing world.
At the end of the day, managing our soil better isn't just about farming. It's about the health of our entire planet. The science is clear, the tools are there, we can make our soil a hero in this story. So the real question is, what are we waiting for?